Good morning, everyone. Am I audible to you? And presentation is visible, everyone. Quickly write into the chat box. Yes, Amit, Deepak. Okay. This two module, first order OD in a higher order. This is our mid-semester syllabus, right? Our ongoing topic is right now in the Laplace transform, thus inverse Laplace transform. Okay. Yesterday we discussed this. Yes. Laplace inverse Fs is equal to f of t, right? And we also discussed some basic formulas of the Laplace transform, inverse Laplace transform, and first shifting theorem also. Problems based on that. Now we quickly revise the formulas, right? Laplace inverse k by s. This is k. Second one, Laplace inverse 1 upon s minus a, which is e power at. Laplace inverse 1 upon s plus a. This is e raised to minus 18. And Laplace inverse 1 upon s square plus k square, which is 1 by k sine kt. And Laplace inverse s upon s square plus k square, which is cos kt. Laplace inverse 1 upon s square minus k square. This is 1 by k sine hk. Laplace inverse s upon s square minus k square. This is cos hkt. And the last one, 1 upon s power n. When this is the integer, then n minus 1, n minus 1 factorial. Integers. T raised to n minus 1 divided by gamma n for fractions. Okay. We discussed these formulas as well as the first shifting theorem problems also. Now continue with this problem based on this first table as well as the first shifting theorem. Now today's first question. One minute. Find inverse Laplace transform of three upon s square plus 6s plus 8. Okay. Now we find the solution. Laplace inverse 3 upon s square plus 6s plus 8 is equal to, now we can see over here, this is s square plus 6s plus 18. That is the polynomial, right? Therefore, in this polynomial, if we want to convert into the Laplace inverse formula, therefore we need over here the perfect square. But for this perfect square, this last term is not correct, right? How can we check that the last term? The last term formula is middle term square divide by 4 into first. Middle term is a 6s square divide by 4 into the first term is a s square. Therefore, 36s square divide by 4s square. S square, cut it out. 4 nines are 36. Therefore, last term is 9. The correct last term is 9. Therefore, we have to divide into two parts. 3 into s square plus 6s plus 9 plus 9. Okay, 18 divide into the two parts. 9 plus 9, right? Now, Laplace inverse 3 upon, this is the perfect square of which term? S plus 3 whole square, and this is the 3 square. Okay. Now, using the first shifting theorem, S plus 3, therefore here multiply with e raised to minus 3d. Laplace inverse remaining is 3 upon s square plus 3 square. And this bracket is the formula of the which term? Write into the chat box, everyone. The bracket value is the formula of the which function? Laplace inverse 3 upon s square plus 3 square is equal to, write your answer quickly into the chat box. Laplace inverse 3 upon s square plus 3 square. Yes, Karnavi, very good. Other students, write your answers. Raj Kishore. Yes, Kunal. Sushil Kumar, Om Prakash, Rishi, Govind Kumar, Hanuman, Mihir. What's the answer? 3 upon s square plus 3 square. Yes, e raised to minus 3t as it is. This is the sine theta. This is our answer. Okay. When the polynomial present into the denominator or into the numerator, therefore first find the last term, and last term is wrong, then find the correct value and then apply correct last term. That's why this is convert into the perfect square. Okay. You can also judge like that. This is s square plus 6s, right? Therefore, s square square root is s. Mute your mic. S square root is the s, and 6s, right? 2 into s, 6s divided by 2s. Therefore, what is the remaining? 3. And 3 square is our last term. This is the 9, right? This is the other method to find it the last term also. Quickly note it down this question. If done, then write yes into the chat box. Complete this question, then quickly write yes into the chat box. Okay, now the next question. Okay, Saurav. Second question. Find inverse Laplace transform of s plus 2 divided by s square plus 4s plus 8. Okay. Now quickly tell me what is the correct last term of the denominator. Which value is the correct last term of the denominator polynomial? Yes, yes, very good, Amit. What about the other students? In place of 8, which term is the correct last term? Yes, Kunal, Parnavi. Yes, what about the other students? Yes, Kinjal. Yes, the correct last term is the 4. Therefore, 8 divide into the 2 part, 4 and 4. Right? Laplace inverse s plus 2 as it is, divide by s square plus 4s plus 4 plus 4. Yes, Roshan, Raj Kishore, very good. Okay. Now, denominator convert into the perfect square. Therefore, s plus 2 divide by s plus 2 whole square plus 2 square. Yes, Kunal, very good. Now, listen, everyone. When into the denominator, s plus 2 is here, and when we have to apply the first shifting, then also check our numerator. Here, the term is not constant. Here, again, the term with the s. Therefore, this one and this one is the similar term, then we can apply the first shifting. Otherwise, not. Okay, if here s plus 2 and if here s plus 3, then we can't apply the first shifting directly, right? We need the more simplification. But here the similar term, that's why we can apply the first shifting. Therefore, e raised to minus 2t Laplace inverse. Now plus 2 is removed from here, numerator as well as the denominator. S upon s square plus 2 square. Okay. Now tell me this bracket is the answer of Kunal and Karnavi already wrote the answer. Other students write the answer. S upon s square plus 2 square. That is the inverse Laplace transform of which term? Yes, Saurav, very good. Yes, Deepak Kumar, Murtaza. Murtaza. Yes, Kinjal. Murtaza Diwan. Unmute yourself. Murtaza Diwan. Yes, Rishi, Nitish. Okay. This is post 2T. Yes, Ajit Kumar. Post 2T. Okay, quickly note it down this question. Yes, Kevin. Yes, Trilok ji. Vipin Kumar, Mihir, Hanuman. Okay, everyone, I think done this question. Now move on to the third question. Example number 3. Find inverse Laplace transform of 2s plus 2 divided by s square plus 2s plus 10. Now quickly find the correct last term of this polynomial, everyone, and write your answer into the chat box. Correct last term. Apurva, this question is over. Now no need to write. Right? Correct last term of this polynomial, everyone. Yes, yes. No, Roshan is not correct. Govind Kumar ji is not correct. 5 is not the correct last term. Yes, Amit, very good. Find using the formula, everyone. If you didn't analyze directly, then find using the formula. Yes, Raj Kishore. Yes. Yes, Saurav, very good. Yes, Trilok Kumar ji. Okay, Laplace inverse 2s plus 2 divide by yes. Anyone want to say something? Sonu Kumar ji, mute yourself. Yes. Didn't want to start your camera also, right? You want to write with me 2s plus 10. Okay, 1 minute.
Yes, ma'am. Ma'am, एक doubt.
Yes. 1 is the correct last term, right? Laplace inverse 2s plus 1 divide by s square plus 2s plus 1 plus 9. And from the numerator, 2 taken common, therefore s plus 1. Therefore, Laplace inverse 2s plus 1 divide by s plus 1 whole square plus 3 square. Now s plus 1, therefore plus 1. Therefore, apply the first shifting e raised to minus p. Therefore, the remaining term is 2s s square plus 3 square. 2 right outside, 2 e raised to minus p, Laplace inverse s upon s square plus 3 square. And this is the cos 3. If here s plus 1 is not present, then we can't apply the first shifting directly, right? That's why we have to apply here s plus 1 into the term. Otherwise, we can't apply this. And students, be careful, right? You have to start your mic only for the answers. Okay, quickly note it down this question. Okay, now the next question, fourth one. Example number 4. Find inverse Laplace transform of s plus 7 divided by s square plus 8s plus 25. Now quickly find the correct last term of this polynomial. Always this kind of the question, then first focus on to the denominator, everyone. S plus 7, s square plus 8s plus 25. Yes, other students also check yourself. What is the correct last term? Only Amit, Kunal, then Raj Kishore, Karnavi, Kinjal, Priyanka. What about this answer? Rishi, Deepak Kumar, Mihir. This is very easy funda. You can learn in your school days. Quickly check that and what is the correct last term? Write into the chat box. Murtaza, write your answer into the chat box. Yes, Saurav, very good. Yes, Saurav, correct. Priyanka, write your answer. Sudarshanji, Bipin Kumar, Sonu Kumar. Sridhar, Roshanji. Yes, Priyanka. Hanuman, Mihir, Deepak, write your answer quickly. When this s square plus 8s, then what is the last term? Then this is converting into the perfect square. Yes, Raj Kishore. Yes, Ajit Kumar. Yes, Govind Kumar. Very good. What about Sridhar, Deepak, Mihir? Today your attendance based on your answers, right? In the chat box, your answer is not there, then you mark as absent today. First, we change the denominator s square plus 8s plus 16. Therefore, 25 divide into two parts, 16 and 9. Right? Therefore, plus 9. Now here, into the denominator, that is s plus 4 whole square, right? Therefore, here we need also s plus 4. Then we can apply the first thing. And therefore, 7 divide into the two parts. Yes, going to be 4 and 3. Therefore, now apply. First, convert into the perfect square. No, Rishi. First, we apply the first shifting. Then, after we are giving the perfect, individual denominator. s plus 4 whole square plus 3 square. Now for s plus 4, apply the first shifting. E raised to minus 4t. Laplace inverse. Remaining term is s plus 3 divided by s square plus 3 square. Now apply the first shifting. Individual denominator. Okay. Therefore, e raised to minus 4t into the bracket Laplace inverse, yes, Kinjo, s upon s square plus 3 square plus Laplace inverse 3 upon s square plus 3 square. Therefore, the answer is e raised to minus 4t cos 3t plus sine 3. This is our final answer. Okay. Again, see the previous slide. In this question, we convert the denominator's polynomial into the perfect square as well as into the numerator. We have to need s plus 4. Therefore, 7 divided into 2 parts, 4 plus 3. Okay. Then first apply the first shifting and then after apply the individual denominator. Any doubt in this question? Because write your answer before my answer, okay? Now the next question. Find inverse Laplace transform of 3s plus 7 divided by s square minus 2s minus 3. Now, what is the correct last term of the denominator? Other students also try your question. S square minus 2s minus 3. Yes, Karnavi, very good. Yes, Saurav. Yes, Saurav, very good. Raj Kishore, Amit. Amit, when we write minus 1, then this is not the perfect square. S square minus 2s minus 1 is not a perfect square. When we write the perfect square, then the last term with the positive sign. If you remember the factors. No, Roshan. Plus 1, plus 2, this is plus 3, but here the minus 3. Therefore, again, divide minus 3 in 2 parts. No, Amit. Everyone think about that. Laplace inverse. I'm changing over here. First the denominator. S square minus 2s plus 1. Then this is the perfect square. Now here plus 1, but in the question minus 3. Therefore, which term is put it over here? Therefore, this is converted into minus 3. No, Rishi. Yes, Kunal, very good. Minus 4. Right? Minus 4 plus 1, therefore minus 3. Now this is the perfect square of s minus 1 whole square into the denominator. First we change the denominator. S minus 1 square minus 2 square. This is s minus 1 square. Therefore, in place of this s, we need s minus 1. Therefore, we directly put it over here. Now, when you open this, therefore 3s minus 3, right? Now, 3s plus 7. We convert into 3s minus 1. Therefore, this is 3s minus 3, right? Therefore, we have to put over here plus 10, right? Therefore, this is plus 7. Therefore, here plus 10. And Saurav wrote the correct answer, right? Before 2 to 3 minutes. Therefore, 3s minus 1 plus 10. Clear, everyone? Now, s minus 1, therefore, apply the first shifting. E raised to t. Now, what is the remaining term? 3s plus 10 divide by s square minus 2 square. And now apply the separate denominator. Okay, quickly note it down. Then I will write into the next slide. Everyone clear this logic? Last term is always with the positive sign. That is never negative. Plus 1 minus 4, this is minus 3. 3s minus 3 plus 10, therefore 3s plus 7. When you go reverse, then you can also get it this correct term. Then your steps will be correct. Okay. Therefore, e raised to t into the bracket Laplace inverse 3 taken, okay, no problem. 3s divided by s square minus 2 square plus Laplace inverse 10 upon s square minus 2 square. Therefore, e raised to t taken common, Laplace inverse. Everyone write the answer of this bracket. Very simple. Plus 10 taken common, Laplace inverse 1 by s square minus 2 square. Yes, very good. Yes, Roshan, very good. E raised to t, this is cos h2t plus 10 by 2 because 2 is not present, therefore divide by 2 and multiply by 2. Then this is convert into the sign. Yes, Kunal, Kinchal, everyone correct your answer. 2 5s are 10. Therefore, final answer is e raised to t 3 cos h2t plus 5 sin h2t. I think everyone correct this method in your mind. Any doubt regarding this method? Okay. Now the next method. division by S. Division by S. If Laplace inverse Fs equal to f of t, then Laplace inverse f of s by s equal to integration 0 to t f t dt. Okay, division by s. If Laplace inverse f of s equal to f of t, then Laplace inverse f of s by s, then integration 0 to t f t dt. Clear, everyone? Now the first question. If you want to discuss something, then you can raise your hand. Any doubt, then you can also raise your hand. Okay. Find inverse Laplace transform of 1 upon s plus 2. Yes, Ajit Kumar, 1 minute. This is the previous slide. Ajit Kumar, when you run this slide, then quickly write yes into the chat box. Ajit Kumar Pandit, done this slide. Now, first focus on that part. This is the basic function. Laplace inverse 1 upon s plus 2. Therefore, e raised to minus 2. Okay. Now, Laplace inverse, we know that f of s divided by s. Therefore, integration 0 to t. This is our ft. Therefore, use this formula here. 1 upon s plus 2 integration 0 to t e raised to minus 2t dt. Apply the normal integration and apply the limit. Okay. Therefore, e raised to minus 2t divided by minus 2, 0 to t. Now, negative sign, therefore, first apply the lower limit. Therefore, negative is the positive. Right? Therefore, 1 by 2 taken common, 1 minus e raised to minus 2t. This is our answer. Clear, everyone? Note it down, this question. Yes. Clear this concept, everyone? Any doubt? Then you can raise your hand. And now the next question. Find inverse Laplace transform of 1 upon s square plus 9. Okay. What is the basic function inverse Laplace in this question? Quickly write into the chat box. Basic function is 1 upon s square plus 9. What is the Laplace inverse of 1 upon s square plus 9? Quickly. Everyone write your answer into the chat box. Yes, Kinjal, very good. This is 1 by 3 sine 3t. Yes, Amit Kumar. Right? Now, this is our f of t. Okay? Now, as per the formula, Laplace inverse fs by s, integration 0 to t, yes, Kunal, very good, ft dt. Therefore, Laplace inverse, write our whole question here, 1 upon s square plus 9. Therefore, 0 to t, 1 by 3 is the constant. Therefore, write outside of the integration, sine 3t dt. What's the integration of sine function? This is minus cosine. Divide by 3. 0 to t. Therefore, 3 3s are 9. 1 by 9. Minus sign. Therefore, apply for the lower limit. What is the value of the cos 0? Cos 0 value is? Yes, Sridhar, Sanatan, everyone write your answer into the chat box. Yes, Sudarshan, Sushil, Sridhar. Write your answer into the chat box. Om Prakash also. Mihir Ravalia. Okay. Cos 0 is the 1, right? Yes, Amit Kumar. Minus cos 3. This is your final answer, everyone. Yes, sir. This is the final answer. 1 by 9, 1 minus cos 3. Quickly note it down, everyone. Done this question? Okay, now the next question. Find inverse Laplace transform of 1 upon s square plus 2s plus 2. Okay. Now first, we have to find this part. Then after 1 by s. Okay. Laplace inverse 1 upon s square plus 2s plus 2. And this question is same like the previous property, right? Changing our last term. Tell me, in place of 2, we have to put it over here. In place of 2, we have to change. Yes, very good, Rishi. Sridhar Kumar, Om Prakash, Sushil. Write your answers. Therefore, Laplace inverse 1 upon s square plus 2s plus 1 plus 1. Okay. Therefore, Laplace inverse 1 upon s plus 1 whole square plus 1 square. Therefore, e raised to minus t Laplace inverse 1 upon s square plus 1 square. And this is the sine t. Therefore, e raised to minus t sine t. And this is f. Okay. Now division by s. Clear up to this step? That is same like the previous properties question. Now we apply over here the formula Laplace inverse fs by s. Write in each and every question this formula. Therefore, this formula is, remember in your mind, ftd. Now apply our question here. 1 by s square plus 2s plus 0 to t e raised to t or e raised to minus t sine t dt. And apply this integration using this rule, integration e raised to ax sine bx dx. Use this. Therefore, into the bracket e raised to minus t divide by 1 square or minus 1 square plus 1 square into the bracket minus sine t minus cos t 0 to t. Now this 1 by 2 taken common. Apply this limit. Therefore, minus sign also taken common. Therefore, plus. This is converting into the plus. E raised to minus t sine t plus cos t. Now apply the limits. Therefore, minus 1 by 2 e raised to minus t sine t plus cos t for the t upper limit, and minus e raised to 0 is the 1, sine 0 is the 0, and cos 0 is the 1. Now simplify this. And multiply with the minus. Complete this. Minus apply inside. Therefore, the final answer is 1 by 2, 1. Positive term, write the first. This is the negative term. Sine t plus cos t. Okay, this is the answer of the question. Yes, am I audible to you, everyone? Now, this kind of the question you have to do into the homework. Please note it down one question. Laplace inverse 1 by s square plus 4s plus 5. And answer of this question, you can do it yourself, right? Answer is 1 by 5, 1 minus e raised to minus 2t, 2 sine t cos t. Quickly do it this question, everyone. Everyone, quickly complete this question, right? And if complete this question, then write yes into the chat box. This is the previous slide of the question. Find inverse Laplace transform of 1 by s square plus 2s plus 2. First, we solve this thing using as per the previous property. Then apply this rule, division by s, therefore integration 0 to t ft dt. Okay. Therefore, divide by s. Therefore, apply over here integration over 0 to t and ft dt. Now, using this rule of the exponential and the trig function multiplication, right? And then after minus sign apply inside, then we can get it this answer. Now, same way you can do it this question, question number 4 yourself. Okay, quickly do it, everyone. Any doubt, then raise your hand or you can unmute. First raise your hand, then I will give the permission for unmute yourself. Right? Quickly do it this question, question number 4, everyone, and write yes into the chat box. Complete this question, then write yes into the chat box. Quickly. Answer is here. Okay, everyone. Yes, Kinjal, Priyanka, Sudarshan. Sudarshan ji, unmute yourself. Sudarshan Kumar Sharma.
Yes, ma'am.
Yes, you wrote answer of every question in the chat box today.
सॉरी मेरा हेल्थ इशू चल रहा है इसीलिए थोड़ा
What? क्या हुआ है?
मेरा हेल्थ इशू चल रहा है मैम, थोड़ा फेवर और गला में थोड़ा दर्द हो रहा है ज्यादा.
Okay. Hanuman ji, unmute yourself. Hanuman. Hanuman Kumar. Yes, Mihir. Mihir Ravalia. Amit, then Saurav, Roshan. Other students, write your answer of this question. If done this question, you get it this answer, then quickly write into the chat box. I am waiting for your response. Yes, Sushil, Om Prakash, complete this question. Kevin, Sridhar, Raj Kishore. Okay, Kinjal. Yes, Sridhar, unmute yourself. Sridhar Kumar. Sridhar Kumar, quickly unmute yourself. Yes, Om Prakash. Om Prakash. Okay, today we discuss the problems based on the first shifting theorem, right? And one most important method when the polynomial into the denominator, therefore first convert polynomial into the perfect square, right? And convert this, as well as the next property is division by s, then integration over 0 to t ft dt. Okay, thank you very much everyone. Have a good day and do hard work for your midterm exam. Any doubt, then you can send me message to me or discussion to the lecture or lab session also. Thank you very much everyone. Have a good day.